Dear students, now we are going to see the subject linear integrated circuit. The subject code is EC3451. Under that, the topic is constant current source. On the completion of this constant current source, the students will be able to describe the frequency response characteristics of operational amplifier working as a constant current source, and they explain the types of constant current source. A constant current source makes the use of the fact that for a transistor in active mode of operation, the collector current is relatively independent of the collector voltage. The basic constant current or the current mirror circuit is shown in figure. Here the collector characteristics of common emitter transistor is shown in figure 2. The transistor Q1 and Q2 base are connected together, and this is connected to the collector of Q1, and the circuit is biased with the help of the biasing supply VCC. Both the emitter terminals are connected together and is connected to ground. Here the transistor Q1 and Q2 are the matched in the circuit is fabricated using IC technology. The base and emitter of Q1 and Q2 are tied together and thus have the same VBE. In addition, the transistor Q1 is connected as a diode by shortening its collector to the base. The input current I reference flows through the diode connected transistor Q1 and thus establishes a voltage across Q1. This voltage in turn appears between the base and emitter of Q2. Since Q2 is identical to Q1, the emitter current of Q2 will be equal to the emitter current of Q1, which is approximately equal to I reference. As long as the Q2 is maintained in active region, its collector current IC2 equal to I0 will be approximately equal to reference current. Since the output current I0 is a reflection or the mirror of reference current I reference, the circuit is often referred as a current mirror. Analysis. The collector current IC1 and IC2 for the transistor Q1 and Q2 can be expressed as IC1 of T is proportional to equal to alpha into IE, the saturation current IES into e power VBE1 by VT. Similarly, IC2 of T equal to alpha into IES into e power VBE2 by VT. IES is the reverse saturation current in emitter junction and VT is the volt equivalent of temperature. From equation 1 and 2, VBE1 equal to VBE2. So we obtain IC2 equal to IC1 equal to IC equal to I0. Both the transistors are identical. So IC1 equal to IC2. Apply the Kirchhoff's current law at the collector of Q1 gives the reference current I reference is equal to IC1 plus IB1 plus IB2. So reference current can be obtained by substituting this in equation. So IC1 plus IC1 by beta plus IC2 by beta equal to IC1 plus 2 IC1 by beta. Here IC1 equal to IC2 equal to IC equal to I0. Solve this equation 4. We are getting I reference is equal to VCC minus VBE on by R, or I reference is equal to IC1 plus 2 IC1 by beta equal to IC1 into 1 plus 2 by beta. So IC equal to IC1 equal to IC2 equal to I reference divided by 1 plus 2 by beta. So beta by beta plus 2 into VCC minus VBE on by R. That means substitute this reference current. I0 is equal to I reference. From equation 5, beta divided by beta plus 2 is always greater than 1 is almost unity, and the output current is I0 is equal to the reference current I reference, for which the given R1 is constant. Typically, the output current varies by about 3% for the betas between 50 to 200. The circuit, however, operates as a constant current source as long as Q2 remains in the active region. Widler current source. Widler current source, which is particularly suitable for low value of current to overcome the limitations of constant current source RE to the emitter terminal of Q2. The circuit differs from the basic current mirror only in the emitter resistance RE that is included in the emitter lead of Q2. Due to RE, the base emitter voltage VBE2 is less than VBE1 and consequently the current I0 is smaller than IC1. The ratio of collector current IC1 and IC2 using this equation IC1 by IC2 equal to e power VBE1 minus VBE2 divided by VT. Taking the natural logarithm on both sides, we are getting VBE1 by VBE2 equal to VT into ln of IC1 by IC2. Writing the Kirchhoff's voltage law for emitter base loop, VBE1 equal to VBE2 plus IB2 plus IC2 into RE. So VBE1 minus VBE2 equal to 1 plus beta plus 1 into IC2 into RE. So VT ln of IC1 by IC2 equal to 1 by beta plus 1 into IC2 into RE. A relation between IC1 and reference current I reference is obtained by writing the Kirchhoff's current law at the collector point of Q1. So I reference equal to IC1 plus IB1 plus IB2. I reference is also be written as IC1 plus IC1 by beta plus IC2 by beta. So neglecting IC2 by beta, so I reference is equal to IC1 into 1 plus 1 by beta. So I reference is equal to VCC minus VBE by R1, where beta is greater than 1. So IC1 is equal to I reference. Wilson current source. It provides an output current I0 which is very nearly equal to the V reference and also exhibits a very high output resistance. Analysis VBE1 equal to VBE2, IC1 equal to IC2 and IB1 equal to IB2 equal to IB. At node B, IE3 equal to 2IB plus IC2, that is equal to 2 by beta plus 1 into IC2. IE3 is equal to IC3 plus IB3, that is IC3 into 1 plus 1 by beta. From equation 1 and 2, IC3 into 1 plus 1 by beta equal to IC2 into 1 plus 2 by beta. From equation 1 and 2, we obtain IC3 equal to I0, that is equal to IC2 into beta plus 2 into divided by beta plus 1. IC1 is equal to beta plus 2 divided by beta plus 1, since IC1 equal to IC2. At node A, reference current I reference equal to IC1 plus IB3 equal to beta plus 1 by beta plus 2 into I0 plus I0 divided by beta. That I reference is equal to beta square plus 2 beta plus 2 divided by beta square plus 2 beta. And the I reference is written as VCC minus 2 VBE by R1. I0 minus I reference equal to 2 divided by beta square plus 2 beta plus 2. I reference is very small for modest value of beta. The output resistance is greater than Widler current source, but the output resistance greater than Widler current source. The possible questions are: why is constant current source used in differential amplifier? Why is collector resistance replaced by a constant current source in a differential amplifier? Thank you.